What's up, guys? My name is Alberto Muner, and today we're going to do feature selections. This is lab 4 for SRT521. So, in this lab, uh, the objective of this lab is we will explore several ways to handle imbalanced datasets and feature selections method and classifier. This is lab 4, task 1-2A. The instruction is to create a Python script to perform the calculation of how many instances of its class, right? So this one here, 0 and 1, malware and benign. And also it will total samples of benign and malware. And so let's run this program. I have to run it to that command line because there's so much that it runs after here. It checked for each line. Anyway, this is the total samples of files, benign and malware, and they were itemized here, counted. There are 966 benign and 393 malware. Okay, so remember what we're just doing here is actually balancing the data set, right? So what we're doing right now is random oversampling. That means like this is the initial count. This is benign. We know that benign is more than the malware, right? So what random oversampling is that it increase the less count, which is the malware, and make even with the benign. So that's what the random oversampling does. And as you can see it here. And the part of the code that does that is here, right? Yeah, so it's just simply even up things, the random oversampler, right? It creates a variable ROS, and then it will make even. And basically the smooth even technique, making even technique, is that it's almost the same as the random oversampling. It's just it randomly collect existing malware collection randomly, and then it will make it even and counts of the benign-ware. So that was a smooth. It's more kind of like sophisticated technique, and generates synthetic example to balance the class distribution. So that's what a smooth sampling doing. And this is part of the code where it does the smooth analysis. It creates smooth variables there, and it plug in the library for smooth, and it does everything, the splitting and collecting and adding and so on here, right? Counts after smooth with this. We can see it here, right? So it's pretty much almost the same as random oversampling, but like I said, this is it's like it's collect more sophisticated way. And for random undersampling, just think of it as the reverse of the random undersampling, where the less count over here, the less count add up more to even up, where the more count will cut it off to even up with the last one. So that's what the random undersampling does over here. It gets actually smaller, right? So now basically the malware initially is 393, so this is steady. It didn't get touched. The benign get cut up dramatic samples. So yeah, that's what the random undersampling does. And this is the part of the code where it does that, random undersampling, right? The majority gets cut off. Okay, after the balancing the dataset, we will have to move on to the task 2, which is feature selections. So this program will simply select the features for us, right? In this, we will have to we will have to select 15 features, and using T2, right? And also mutual information classifier right there. So it selected both 15 features in this case, right? Slightly different, but there are similarities, like 6, 97, 28, 38, 39, 71, right? But they're both 15 features, right? Yeah, so for those two output, here's a part of the program that does that, right? From selecting 15 features, we use select KBS in G2, and also select KBS mutual info classifier, right? So we'll move on to percentiles and G2 for SBC, right? So these two here is the result for this code, part of the code. And select percentile with mutual info is this one here. So obviously they have pretty much the same counts of selected features. So these two parts are select KBS, and this two part here like select percentile. So obviously select percentile select more features. That's what we observe, right? So this feature selections will have a confusion matrix, right? And also the SBC classification report, we have F1 score of 94%. classified as right, and then 84% on the malware part. Selection method, and that's trying to and validate a Bernoulli NB model and select the best method, right? And so just run this code, and so those are the features that were selected, pretty much showing in it's just collect the headings, and obviously, instead of this, I create a program to, so whichever you like, you can select this one or this one, previous one. But this one we're doing the Bernoulli, so it create also a classification report and confusion matrix when we use the Bernoulli NB, right? Yeah, so it does this report F1 94 and 86, which we compare. It's 84 over here, 94, pretty much the same almost with the Bernoulli method, right? So this is part is loading the list of features selected and the machine learning model through Pickle, right? This is a part program that does that. So we can just run it, and it should load in the memory. Once again, task 3 is a model persistence and live classification, right? So we loaded the Pickle. Next one, we will have to enumerate the files that we have downloaded in Seek, right? So in this Python program, we loaded the model file, right? And this is our actual file, and then we will have to scan the Seek extracted file, right? And then we will have to output the log file in the JSON format. So yeah, this is how it reads in the Seek directory, and then using kappa again, we will have to scan the file, rescan the file, and we will kind of like match it to the model. And so yeah, this is how it's being done. There's a little bit of work in progress here. I'm a little confused to use the Pickle file. I have to do more search about that. I've spent so much time with lab 4 already, and I think I got this one 90% of the lab. It's just this part to compare the Pickle file to the kappa scan file. That's where I'm getting a little bit of hiccups. So when I classified it, I just classified as 1 and then it printed in a JSON format and so on. So let's see how this program does. I will need to revisit this part in the future so that my program will do the way we expect it. But 90%, 95%, I think I have an idea what to do in the future. It's just it needs more time to finish that part. So let's run the program. And guys, I don't need to show you how I downloaded the file in Metasploit, right? Because I've done that in lab 1 anyway. So now it's running. The program is running right now. It's analyzing the 4 files that I uploaded into the Kali, right here, right? And then I hashed it just to make sure if they are matched or not. So yeah, so this part where when I downloaded it from the Metasploit, it went to this directory here, right here, right? And these are the MD5 sum. So now it's still analyzing. There you go, guys. It's finished scanning the file into the zip kappa directory, right? And so let's go and take a look at the file that we're scanned. It's the JSON, right? JSON should be here. So let's open it. Okay, let's see if it matches what we have here. So the time, guys, it's 16:32:39. So this is live classification, and there are 4 files listed here. So and those are the MD5 hash. Okay, let's see if it matches to the Seek directory. And it does, right? As you can see here. Yeah, over here, F9 right there, 7B, and also it matches the one we have in Kali right here. So if you can take a look, they all classified live, and the timestamp is there. Like I said, experiencing a little hiccup on classification function. So I will have to fix that in the future. But thank you for watching, and I hope you enjoy my video, and have a nice day. Bye bye.